Working on TS-5 here. This thing's been cleaned. You can see everything's been flattened and the wool has been installed. I'm pretty pleased that for the amount of wool that's in here, seems like it holds about 13 grams of methanol at this temperature, which is about 35 Celsius out, but liquid density doesn't matter that much. I mean, it's not going to make that much of a difference for a few degrees, but you know, I weighed it dry, pretty much as you see it here, and then I saturated it and let it drip dry to the point where there were no longer any drips coming out of it, at least for 15 seconds or something. And it weighed about 13 grams heavier, and then slowly dried out. So anyway, I'll have some pictures and stuff associated with this. You can see this wool chunk, kind of a big, long, tubular tampon looking thing, supports the center. There's two sections of screen and they overlap here in the center, more or less. One of them overlaps more than the other. That was a mistake. But anyway, I wanted to get good firm pressure there. So I just used an old chunk of wool that I had. I rolled it up. Of course, it didn't want to go in there. So I just stick a 1/2-inch steel plate in there to hold the screens back. And then I wrapped the wool in a piece of paper and then shoved it in the center as I slowly pulled the steel out the other end until the steel was completely out. The wool was more or less centered, and then just gripping the wool with some pliers on one end down through the tube and then ripping the paper tube out, I was able to leave the wool in the center. The wool might have an added benefit of holding some extra methanol. Don't know if that's a plus or not, but it's definitely serving a purpose here. I could have used the metal screen, but this seems to provide a lot more support. And I pushed it down a little bit on either side so there was a vapor path across it. Should be able to pass through the wool itself, but since the vapor line is going to be just on one side, on that side right there, 3/8-inch line, I want to make sure that there's a clean vapor path for everything to get through. So I'm going to have to probably clamp a lot of this stuff up. On this end, this is actually going to be where the thermocouple is installed. The wire is going to go the whole way down through there. It's going to be a flare connection. But I'm going to use this flare connection to hook up my nitrogen tank to purge it. Like I said, everything's been cleaned. I did a couple of soaks in muriatic acid, and then baking soda, and then back. If I let it in the baking soda too long, it seems like I get some black, like some oxidation or something. So anyway, I didn't go as long this time, and then I just rinsed it really thoroughly with water. Still used tap water, didn't bother getting distilled, but it looks pretty clean. So I want to try to get this thing, get some nitrogen in it right away and start brazing so I can avoid further oxidation. With these caps, it's actually the piece of the same pipe that I made the rest of it out of. They're not completely flat, so what I usually end up having to do is just tap them out a little bit and give them a couple little dimples until the crack is small. So, okay, this is my TS-5 thermosiphon evaporator. It has a copper wool wicking structure. This stuff is 4 inches wide. I should show you guys this so you know what I'm actually working with. You can see it's not very thick. It tends to stick to itself a good bit. So there are two pieces that are 150 millimeters long, 4 inches wide, that are layered. And then next to that is overlapped another two of these that are layered. And then till I wrap it around, it's overlapped in two spots. I did that for the stretching portion so that I was able to fully seat everything and it was able to split, didn't get pinched in two spots. So, I don't know if the first part of this video actually saved or not, but I'm getting ready to braise everything up. Everything's been cleaned in the muriatic acid and the baking soda solution to neutralize it. Got a lot of bubbles whenever I neutralized it. This thing holds a good bit of liquid, so it's very encouraging that it wicks quite well. So it's still wet. I ended up running it through the acid and the baking soda twice, and then rinsed it a whole bunch in a pan of just tap water. I didn't get distilled water yet. I don't know why, but anyway, rinsed it out, dumped the pan, rinsed it out, dumped the pan, and repeated. a few times. So it should be pretty clean. I've run a little bit of nitrogen through it, so there should be more or less an inert atmosphere in there, trying to prevent any more oxidation than as much as I can avoid. See how everything clamped up? That's the 3/8 inch vapor line, and then that stub there, which is a 1/4 inch male flare. That is right now for my nitrogen purge line, but later I'll be able to insert a thermocouple in there that's flare style. And then that little sucker there is, that's going to be my first return line that has the wick pinched in it up there. So I just kind of have this whole thing inverted. I will braze the top and then flip the thing around and figure out how to put the other one on the bottom and add, this is another return line that's going to be just a regular 1/4 inch trap. So I'm going to go ahead and get to work. Hey, Mike here. It's Tuesday evening. Been working all day on this thing, and it's pretty well done. I did an initial evacuation on it, pulled it down to like 260 in a few minutes, 260 microns. So I'm pretty confident that there's no leaks, but time will tell. I gotta pull a longer, deeper vacuum. I do have 4 flare connections. So never done flares with a vacuum, so I don't know how those are going to behave. I was going to put a little bit of oil on the seat before I tighten them on, but I forgot to. So I'll just have to wait and see if they appear to be leaking, or if I have any leaks or anything. So I'm not going to get to run this thing tonight. And the first time I did this video 10 minutes ago, I interrupted myself by cussing because I screwed something up. But we'll deal with that. So. A few changes here. A new evaporator. This is TS-5. This is a copper wool evaporator. I'm pretty excited to see how well it works because the wool is packed in there pretty tightly, and it seemed like it wicks really well. It held about 13 grams of liquid methanol. If I soaked it in a pan of methanol and then picked it up and let it pretty much stop dripping, completely stop dripping, and then weighed it, before and after. And that's a fair amount for it to just soak up in there. So I'm pretty excited to see how that works, and it's pretty fine stuff. So hopefully it boils a little bit better. We added a inline thermocouple that's actually sticking into the vapor chamber just a little bit on that side. And see, that's a flare connection with that whole epoxy casting I did a few days ago. There's another one that sticks into the header of the condenser. Same idea, just hanging out in there. So that'll be my my condenser temperature. A few extra lines here. I'll explain that. Vapor line is 3/8 inch. Goes up into the condenser like before, but I did change the plumbing there a little bit. Return line is 1/4 inch now instead of 3/16. And this is what I screwed up. I completely forgot to put a goddamn trap in it. I was really happy with the way this bent. I measured it and bent it, and it fit in there perfectly, but I neglected to put a trap. There are 2 return lines here. I have a stub over here that I can use later, and that's just a straight 1/4 inch tube that goes right in. This one here, on the other hand, is actually pinched, and some of the copper wool extends out into that about yay far, and then I pinched it. The idea there being, I wanted to see if a restriction had any effect on the height of the liquid column. Even though I don't have a sight glass in there, I want to see if added methanol makes any difference. I kind of doubt it, but I was going to put a trap here so I didn't have any reverse flow, but I didn't. And I could probably fix this in about 10 minutes, but I'm not going to. I'm going to go ahead and just run it as is, and run a series of tests, and then I can cut this off later, add a trap, do the testing again, and then later on I can cut this one off and pinch this one off here and just have a regular trap with a full 1/4 inch line. I don't expect the liquid height to be very high, probably not on either one of them, but I'm curious to see what the differences are, and really, even if this restriction can pass enough methanol. We only have to move at 150 watts, like 7 or 8 grams per minute. So it's not a lot. Liquid velocity here in this return line should be around it's like 0.9 centimeters, so 9 millimeters per minute, per second. Excuse me, one centimeter per second. So I don't expect a large liquid column there. But anyway. The modifications here, the differences. I discussed this a little bit with you, Nate. I'm interested to see in the previous series of tests, I was only getting, under infrared, I was only seeing about half the condenser being utilized, and the remainder was dark, which I assume is liquid. And some concerns that liquid's not fully passing through there. So I want to put a bypass line in. So that's what I did. I actually drilled a hole in the bottom pan, and rather than, although it is in the bottom of these divots, you can see that my condenser has these divots in the bottom, these recesses that do, I'm sure, hold some liquid. The return line is just right into the very bottom one of those divots. This one, on the other hand, actually extends up in a little bit. And the idea is that vapor is allowed to bypass. The liquid falling can displace any vapor. If vapor was in there like in this thing before, I was concerned that that it was kind of getting a vapor lock, and it wasn't allowing the liquid to fall very well. I'm not using very much of my condenser surface area to actually do real condensation. So the vapor line actually just is an equilibrium line. So the equilibrium line just runs back up to the condenser top, to the head, right into the vapor line at the top. And I'm hoping that what it does is allows that vapor to be displaced and that liquid in the condenser to fall. I put a valve in place so that I can test it with and without the equilibrium line. Where this got a little fancy is I designed and built a very simple ejector. If you're not familiar with ejectors, you can actually have a video or two on my channel you can check out, but you know, Wikipedia page, whatever. I even have some stuff on my blog about it too, some diagrams and stuff. See, I could have just run the equilibrium line right up into the head, and I think it probably would have had positive effects. I'm interested in the vapor velocity as it comes out of the vapor line and goes into the condenser. Because my previous experience, the liquid just kind of more or less hangs in there, and at the low liquid volume that's draining out of the system, I expect that vapor velocity that I think I calculated it is 8.5 meters per second. I think it's kind of fast. It's like 20 miles an hour or something for going through that little line there. And the fact that it goes from, you know, almost nothing to 8.5 meters per second up this short line and then in here and then more or less stops. I think there's a lot of turbulence that probably happens in there. And all that kinetic energy from the pressure is converted into velocity, and then once it gets in here, it just turns into turbulence. And I think it's wasted energy, and I think I can actually do something with that. So what I did was I extended this 3/8 inch line into about this far, into the 1/2 inch pipe. Then the 1/4 inch line, that's the equilibrium line, just runs up into the bottom of the 1/2 inch pipe here. The idea being the kinetic energy, the velocity of the vapor coming out, is at a slightly lower pressure than it is whenever it's stopped. What Bernoulli's principle, I think it is. So as that vapor leaves the 3/8 inch line and enters into the 1/2 inch pipe, creates a slight vacuum behind it, slightly lower pressure, which the idea being it can draw vapor through the equilibrium line out of the bottom of the condenser and allow that liquid to fall readily, separate out into this bottom pan and then drain back to the evaporator, thereby creating a smaller loop in the condenser itself, where that velocity, that kinetic energy, is kind of conserved, where it's constantly being utilized, and that vapor can flow through here and pretty much push off or push out, or, you know, keep some velocity through here so that condensate can effectively drip away. So there's plenty of internal surface area for the vapor coming from the evaporator to condense out on there. And then, of course, any vapor that makes it to the bottom gets to be recirculated, and the process continues. So we'll see what happens. You know, could be a failure. Might not work at all, but, you know, it's an idea that I have, and I just want to see if it works. So I have a series of tests I can do with this one. First of all, just equilibrium line closed, do a series of runs at different refrigerant charges to collect some data. Then open the equilibrium line, do the same set of tests again, cut this one off, put a trap in, repeat. Depending on what I find with the equilibrium line, I might, you know, leave it open, leave it closed, I don't know. And then of course later on I can just do the regular trap. So anyway, I got to put it all back together and keep evacuating. It's probably going to take all evening until I get it to where I want it. And then tomorrow night I will charge. So that's about it. I got to turn the AC back on. It's getting hot in here.